Hello everyone, welcome back to our YouTube channel. So today we are going to study what is K-medoids, what are the algorithm steps involved in K-medoids, and what are the advantages and disadvantages of K-medoids. So K-medoid is a clustering algorithm that is used to solve the clustering problem similar to K-means. It is the generalization of K-means. So K-medoid is a clustering algorithm which is unsupervised learning algorithm which is used to solve the clustering problems. It is also called as partitioning around medoid algorithm. So first we will understand what is the medoid. A medoid can be defined as a point in a cluster whose dissimilarities with all the other points in the cluster are minimum. So let us consider this an example. So this is the cluster of the some data points. So if we consider this point as our medoid, then the dissimilarity of this medoid with other data points will be minimum. So to calculate the dissimilarity of the medoid C of I and the object P of I, so we are going to use the equation as E equal to mod of P of I minus C of I. Now we will understand the algorithm steps. What are the steps involved in solving the K-medoid problems? So first one is the initialization. So first we will select k random points out of n data points as our medoid. Second step, assign each point to the closest medoid by using any common distance metric methods. So you can use any distance metric methods like Euclidean distance or any other. Third, calculate the cost which is nothing but the sum of the distances of non-selected points from the selected point which is the medoid of the cluster it belongs to. So this is the third step. Step 4, select another random medoid and follow the step 2 and 3. Compare the total cost of present medoid and of the past medoid and choose the medoid with the minimum total cost. So now we will take an example so that you will better get to know how the algorithm works of K-medoid. So in this example we have 7 data points with their x-axis and y-axis values. So to calculate the dissimilarity between the medoid and your object or the data point, we use the formula as E equal to P of I minus C of I. So to calculate the distance between the data point and the medoid, we are going to use the Manhattan distance formula, that is x1 minus x2 mod plus mod of y1 minus y2. So the first step of our algorithm is to initialize, that is to select k random points from the data points. So here we are selecting the two random medoids from the data point, that is 3,8 and 4,2. So these two will be the randomly chosen medoids initially. So now we will calculate the distance between the medoid and the your data point. So for data point 1, that is 7,6, we will calculate the distance for both the medoids to check whether which is the medoid that is near to this data point. So for medoid 1, that is 3,8, we are going to calculate this. So that is 7 minus 3, that this is the your object, that is the data point, and 3 is your selected medoid. So 7 minus 3 comma 6 minus 8, this we have calculated using this formula for calculating the dissimilarity between the medoid and your data point. So we have got the answer as 4,2. Similarly we'll calculate for medoid 2, that is our 4,2. So 7 minus 4 and 6 minus 2. Since these all values are present within the mod, so the answer will always be positive only. So we get the answer as 3,4. As you on the comparison of both of these value, we can see that the data point 7,6 is near to medoid 2, that is 4,2. So the data point 7,6 lies within the cluster where medoid 4, 2 belongs. So similarly we'll calculate the distance for the data point 2, that is 2, 6, and for both the medoids we'll calculate the distance. For medoid 1, that is 3, 8, we will calculate the distance. So here you can see the distance is 1, 2, and for medoid 2 we are getting the distance as 2, 4. So on comparison of both this, we can see that the data point 2, 6 is near to our medoid 1, that is 3, 8. So by visually also, or by observing the data points also, you can analyze that which data point is near to which medoid, or you can use this formula to calculate the distance, or you can, for cross verifying also you can use this formula. So for data point 4, that is 8, 5, we are again calculating the distance for medoid 1. So we get the distance as 5, 3, and for medoid 2 you get the distance as 4, 3. Again you can see that 4, 3 is a small distance, so the data point 8, 5 will lie within the cluster which consists of your medoid 4, 2, that is medoid 2. So similarly you will calculate for all the data points within the data sets. So after calculating the distance for all the data points in the data sets, there are two clusters formed. So as we have taken two medoids at random, so there will be two clusters formed. So the cluster 1 consists of your medoid 1, that is 3, 8, and the data points that are near to the medoid 1, that is 3, 8, and the cluster 2 consists of your second medoid, that is 4, 2, and all the data points that are near to this medoid 2. So the third step was to calculate the total distance. So to calculate the total distance, so we take the sum of distances of non-selected points. Non-selected points are nothing but this is your non-selected point from the selected point, that is the medoid. We are calculating the distance between the non-selected point and the from the selected point. So here your non-selected point is 2, 6, and your selected point, that is nothing but your medoid, is 3, 8. So this is how you calculate the cost, that is cost of selected point, that is medoid. This is the medoid 1, and the non-selected point, that is 2, 6, because 2, 6 lies near to your medoid 1, plus cost of selected point, that is medoid. From cluster 2, medoid is your 4, 2, and the non-selected point is 7, 6, plus cost of your medoid 4, 2 and non-selected point, that is 8, 5, plus the cost of 4, 2, that is your medoid, and non-selected point, that is 7, 4, and lastly 4, 2 your medoid and 4, 7 as your non-selected point. So how you will calculate this cost? So we are going to use the Manhattan distance formula for calculating this. So as we have seen earlier, the formula for Manhattan distance is mod of x1 minus x2 plus mod of y1 minus y2. Since all these terms are present within the mod, the answer will always be positive. So your this will be 3 minus 2 and 8 minus 6 mod, they will be added, plus mod of 4 minus 7 plus 2 minus 6. So similarly you will calculate all this cost for all the data points, or you can say all the selected points and the non-selected points. So after calculating all this, you get the answer as 3, 7, 5, 5 and 7. So you will add all these terms and you will get the total cost as 27. So the total cost when you have the medoid 3, 8 and your second medoid 4, 2, you get the total cost as 27. So your step 4 was to, now again you will select a random medoid from your data set. So I have kept the medoid 1 as same, that is 3, 8, and I have taken the medoid 2 that as 7, 4. So same steps we will follow. We will again calculate the distance for your medoid and your data points from the data set. So for data point 1, 7, 6, again you will calculate the distance. So for medoid 1 it is 7 minus 3 and 6 minus 8. So you get as 4, 2 and 7 minus 7. This is for medoid 2, 7, 7 and 6 minus 4, that is 0, 2. So on the comparison you can see that the data point 1, that is 7, 6 is near to your medoid 2. So it is near to medoid 2, that is 3, 4. So similarly for other data points also I have calculated this distance. So here you can see for data point 2, 2,6, the distance it is near to your medoid 1. So the data point 2,6 will lie in your medoid in the cluster where you have the medoid as 3, 8. Similarly for data point 8, 5, you can see the distance is minimum for the medoid 2. So 8, 5 will lie in the cluster where you have the medoid as 7, 4. So after calculating the distance for all the data points in the data set, we get two clusters. That is cluster 1 consists of your medoid 1, that is 3, 8, and all the data points that are near to your medoid 3, 8, and cluster 2 consists of your medoid 2, that is 7, 4, and all the data points that are near to your medoid 7, 2. Again we will calculate the total cost. So we calculate the total cost as sum of the distances from the non-selected point, that is your 2, 6, from the selected point, that is your medoid. So again we have calculated the cost in the same way as we have calculated in the previous steps. So here we get the total cost as 12. So you have the total cost as 12 when you have the medoid as 3, 8 and 7, 4. So the last step was to compare your total cost. So when the total cost when 4, 2 was the medoid is greater than the total cost when you have 7, 4 as the medoid. That is, as we have calculated in the above steps, that the total cost for when medoid was 4, 2, we have total cost as 27, and when we have taken 7, 4 as our medoid, the total cost was 12. So as 27 is greater than 12, we will reject this medoid and we will consider this medoid, that is our 7, 4. So our new medoid will be 3, 8 and 7, 4. So the clusters formed will be same as we have calculated in the above steps, that is 3, 8, 2, 6, 4, 7 and 4, 2. And cluster 2 consists of your medoid 2, that is 7, 4, and all the remaining data points that are near to your cluster near to your medoid 7, 4. So now we will see the advantages of K-medoid. So K-medoid is simple to understand and easy to implement. It is fast and it is less sensitive to the outliers, but on the contrary it has some disadvantages as well. So the disadvantages are, it is not suitable for the clustering of non-spherical or the arbitrary shaped groups of the objects. Second, it may contain different results for different runs on the same data set because the first K-medoids are chosen at random. So this was all about K-medoids. Thank you.